Here we'll look at even and odd functions along with their integrals. So we'll start with even functions. So an even function is anything where f of x is equal to f of negative x. This is the algebraic way. The geometric way would say these are symmetric with respect to the y-axis. So the nice thing about these is if we're integrating between negative a to a of f of x dx, this is the same thing as 2 times the integral from 0 to a of f of x dx. So this is a result of it being symmetric with respect to the y-axis. From negative a to 0 is the same thing as from 0 to a, since we do have that symmetry. And it's usually easier to evaluate at 0, which is why this is so nice. An odd function is anything where f of negative x is equal to negative f of x. And these are symmetric with respect to the origin. What this means is if you take a graph and you rotate it 180 degrees, it still looks exactly the same. Here we have if an integral goes from negative a to a of f of x dx, it's equal to 0. And this is a result of this symmetry as well. If the right side has a positive area, the left side from negative a to 0 will have the same area, only negative. If the right-hand side is below the x-axis, the left-hand side will be above. So it has this nice symmetry where basically one side will be positive, one side will be negative, and so they'll cancel each other out. So let's look at an example. This one goes from negative 5 to 5. So we'll change this to go from 2 times the integral from 0 to 5. Negative 9x to the 4th is an even function, since that is an even exponent. Negative 9x cubed, 3 is an odd exponent, which means that term is going to go to 0 since it is an odd function. X squared is even. X is an odd function, so that'll go to 0. And then negative 2 is an even function. When dealing with polynomials, we're really looking for even exponents or odd exponents. So this is 2 times. We add 1 to the exponent and then divide to get negative 9 over 5x to the 5th, 1/3 x cubed, and then minus 2x. And this is evaluated between 0 and 5. Sticking in 5, that's negative 9 over 5 times 5 cubed, or 5 to the 5th, plus 1/3 times 5 cubed, minus 2 times 5. Sticking in 0 is just minus 0. And once you work this out, you get negative 11,186 and 2/3. Let's look at another example. So if we think of the graph of cosine, we know it looks something like this. It's symmetric with respect to the y-axis, so it's even. The cosine of 4x is not going to change that. It's going to change the period. It's not going to cycle between negative pi and pi, but it will not change the function and its symmetry. So we have 2 times the integral from 0 to pi of cosine of 4x. We know the integral of cosine is sine, And the 4 on the inside is going to give us a 1 over 4 outside. So we have a 1/2 since we already had a 2. Evaluate it between 0 and pi. So this is 1/2 sine of 4 pi minus 1/2 sine of 0, which is just 0 minus 0. So it's 0. Just because it's an even function doesn't mean this integral isn't going to necessarily be 0. We just can't guarantee it the way we can with an odd function. Let's do one more example. So sine is an odd function, so we can ignore that since that will go to 0. Cosine is an even function. And cosine sine is also going to be an odd function. So this would be 2 times the integral of cosine, which is sine, going between 0 and pi over 2. So we have 2 sine pi over 2 minus 2 sine 0, which would just be 2.